Let me record it. Okay. All right. So let's go back. So we needed to learn how to find the Taylor series, how to find the power series for a given function at a given point. Okay. And if we ask you to find the Taylor series, then you know the formula, but don't use that formula to find Taylor series. It's not the efficient way to do. It's harder to simplify. So what I'm going to do is just find the Taylor power series representation for that function at the given point. Then by the theorem, this is a Taylor series. Okay? Yeah. So all you have to do is just modify the function. You let x to be x minus 1, then plus 1, right? And so let u to be x minus 1, for example. Yes, that's always the relation. Right? Then x is going to be u plus 1. Now, this is a place students make mistakes. Okay, that's the problem. Okay, that is the problem. I cannot help you. Okay, this is so you got this idea. And the question is, how do you, even like remove the parenthesis, okay, then make mistakes. Okay, that's it. So be careful. It's going to be 3 minus u minus 1. It's going to be 2 minus u. Now you are going to use the formula. What formula are you going to use? You are going to use this formula. Right? You're going to use this formula, 1 minus whatever you put there, x is, okay? And you're going to use this formula, okay? Right? And here, x is should be less than 1. You're going to use this formula. Everybody knows this formula. So, but this does not look like that formula, right? 2 minus u, not the 1 minus u. Oh, why not? Then take 2 out. And that looks like that, okay? And the 1/2, and this is going to be half of u to the power n. Okay, then you will get 2 to the n plus 1 and u to the n. Right, and then, sorry, it should be outside. Now, if you cannot do this, you're going to lose 10 points, at least on the finding there. Okay, this is an important skill. And when it's convergent, when half of a u is less than 1. So in other words, x minus 1 is less than 2. So radius of convergence 2. So you got everything. Right? So, I'm asking you to, in my email, I said find the power series for this function. It's going to be natural log of x at a equals 3, for example. Okay, please do this problem. Do you remember the formula for the natural? Okay, we have to use the formula natural log of 1 minus x or 1 plus x, right? Is going to be x is going to be n here, right? Remember it's integral. Okay, integral that this is going to be n 1 over n. It's minus. I have to check that. Okay, so that's the formula. Okay, so natural log of 1 minus x, because when I differentiate, I get 1 over minus x, and using the above formula, that's what we got. Okay, we integrate. We got this from here. We integrate on both sides. Okay. Of this integral. Right? When you integrate both sides, the left-hand side gives you natural log of negative of natural log of 1 minus x The right-hand side is going to be x to the n plus 1 over n plus 1, but the n plus 1 starts from 1. So that's why you change it to the above. All right. So how do you use this formula? You know, I only memorize this. That's the reason I was trying to figure out what is natural log of 1 minus x. Right. So you double check that you can differentiate both sides, whether you can get the same amount. Okay. So you want to express it at a equals 3. So you let u to be x minus 3, right? Then f of x is going to be natural log of x, which is going to be natural log of u plus 3. Okay. Now you're going to use a formula. So above formula, you have to express like a 1 plus u, right? So it's going to be natural log 3, 1 plus u over 3. Okay. And then this is natural log of 3 plus natural log of 1 plus u over 3. So this is very similar to the above one. Then since I already know that above formula, I'm going to change it to negative x, right? Negative 3 plus natural log of 1 minus negative u over 3. Okay, this is my x, right? Then this will be negative. Oops, what happened? Okay, this will be negative here, n negative u over 3 to the power n. Okay, and you simplify it a little bit. And I can move negative sign inside, again, negative, n minus 1 plus 1, n minus 1, doesn't matter. N plus 1, n minus 1 is the same. And here's n, and 3 to the n, and the u to the power n. Okay, and you change it to the x minus 3, then you solve the problem. All right, so that's it. So I said that you must know how to work on this. You can make a problem by yourself. Come on, right? Just do it, okay? So you practice and look at this. You can create several. Yeah, you can look at trying to find Taylor series for power series for a function at a different point. Okay. If you really want to get 10 points from this problem. Yes. Plus one, because there's a negative sign here. Coming from that. I did not memorize the formula for natural log of 1 plus x. Natural log 1 plus x, then just apply this formula direct. Okay. If from the book there's given the formula natural log 1 plus x, you can use that one. Okay. I only got the one for this natural log of 1 minus x. All right, so that's why I don't know why this student lost 10 points. Nothing is on this side. Okay, and I just randomly look at whether you did it, the last problem. Okay, and yeah, this is still okay to do. So he's trying to use a formula for the Taylor series and can never make it. Nobody got the right expression using the formula for the Taylor series. Right. All right, so that's then about series, that's really a problem. So when we try to find the radial interval of convergence, you have to really look at the endpoints. Interval convergence. Okay, you cannot just find the radius of convergence. Okay, for example, I just randomly look at it. Okay, for example, like this. Okay, like this problem. Okay, look at this problem, right? You can use the ratio test. Usually we use rotor test or ratio test, doesn't matter. So use a ratio test, an plus 1 over n, right? And that is n plus 1, x to the n plus 1 absolute value. Don't forget that. It's very important. Okay. So after simplifying, you will get this. Okay. And clearly the limit is going to be x as n approaches infinity. So this limit is going to be absolute x, and clearly it means the power series. Okay, it is absolutely convergent for this lesson 1. Divergent for this greater than 1. So how about the endpoints, right? And almost nobody pay attention to the endpoints. I'm surprised. Yeah, nobody. So, okay. So how about when absolute x is equal to 1? Because you have to find the interval of the interval of convergence. Okay, the radius convergence already know that it's 1. Interval convergence is not going to be from negative to positive. It's maybe including the end point. Okay, so when x equals 1, this is a power series. Okay, becomes series like this. This is a divergent. You know why? Why you know how, right? Why it's divergent. When x equals negative 1, you get this. This is a convergent. Okay, so that means the interval of convergence includes left end point. It does not include the right hand point. Okay. So the next problem. Let's just look at this, right? It's the same problem, right? So I was asking to figure out whether this is a Basur convergent, whether it's conditional convergent, whether it's divergent, right? And this student says that it is a Basur convergent. Okay. Okay. And it's harder for me to understand the argument here. You only prove that the nth term approaches 0. Then jump to the conclusion it's a Basur convergent. The nth term approaches 0. You can only use that to prove it is convergent by the alternating series test. And it's obvious it's not absolute convergent by the P series test. Why it's not convergent? Because this is a divergent. Come on, right? This is a divergent. Everybody knows that, right? If P is less than 1/2, it is divergent. Okay, and so clearly, and if we let this one, it's approaching 0. It's decreasing, approaching 0. So this implies the alternating series is convergent by the alternating series test. But I did not see any words on this, on his solution says alternating series. He just say the nth term approaches 0, therefore by the comparison test, this is a convergent absolutely. So it's very hard, it's headache for me, you know, it's hard to give credit sometimes. If the argument is completely irrelevant. Okay, so this is a convergence. Therefore, it's not absolute convergent, it is convergent. So it's conditionally convergent, all right? Okay, it is conditionally convergent. Next one is using the integral test to, but there was a small typo, so actually start from 2 actually, okay? So it's n natural log n. This is a typical example we did before. We want to determine when it is convergent, right? When it's convergent, here's P is positive, okay? This is a convergent, the function is going to be 1 of x natural log x to the power P, right? So clearly it's decreasing, okay? You don't need to worry about that. So, but the integral from 2 to infinity, okay? We yeah, this is going to be the limit. B approaches infinity, right? So the entire derivative of that function is going to be, you let u to be natural log x. So that is just going to be 1 over p dp, du, okay? Because du equals 1 over x. And this is a convergent or divergent, depends on, so we know that 2 to the infinity, actually this is a natural log 2 to infinity, okay? This have only 2 possibilities. This is going to be infinity if p is less than or equal to 1, and then that's going to be finite if p is greater than 1, okay? You don't even evaluate it, we know that, okay? So that's why this is the infinity if p is less than or equal to 1. It's a finite if p is greater than 1. So that means convergence. So when p equals p, of course it's convergent. That's a special case, right? It's a special case. Yeah, here's a problem. Okay. First of all, I have to explain. Sine n has no limit as n approaches n. That's the important fact. Limit sine n as n approaches 0 does not exist. And we don't know. You cannot find it. Okay, actually can be proved that no limit. Okay, it does not approach any fixed number. Only property you can use is sine n is less than or equal to 1. Okay, that's it. It's always between negative and positive 1. But that's enough. We look at the denominator. The denominator, right? Sine 2 minus sine n. What is the largest possible value? When sine n is smallest, 2 minus 1, right? What is the smallest possible value? The largest, sorry. When n is going, sine n is going to be negative 1, so it's minus negative, so 3, the largest possible value. The smallest possible value is going to be 2 minus 1. Okay, so this is a inequality. Okay, so if we put in the denominator, this is always between 1/3 and positive 1. So the nth term does not approach 0. Right? The nth term does not approach 0. Right? Therefore, yeah, the nth term is not going to be 0. I did not, actually the limit does not exist because the sine n, the limit does not exist. Okay, of course, it's not going to be 0. It does not exist, it cannot be 0. Okay, so that's why it is divergent by the nth term test. Right, for divergence. Okay, so I'm looking at this student's solution. First of all, he create the name of test called a direct compression test. I never heard about that. Okay. Okay. So, but I don't know where it's from. Direct compression test. So he only wrote, you know, it's harder to give quiz. I'm very generous. I still give him 5 points out of that. It's harder to tell. So he only wrote this. Okay, that's the first line. Then he said by the direct compression test, and it is convergent. Okay. Okay, it is convergent. First of all, I don't know where it is direct compression test. Okay, and it's convergent. Nothing is convergent here. Even the nth term is not convergent. The series, of course, is not convergent. It's divergent, right? Yeah. So no comparison. I don't see any inequality there. So there's no comparison. Technically is used. All right. So let's take a look at the next problem. Okay. Yeah, let's choose this number. All right. When I look at this series, I know this is convergent, okay? Absolute convergent. I guess I just, first of all, you have to, when you look at that, first you ignore the negative sign to make can you see it's convergent or not? If it's convergent, this is absolute convergent. If it's absolute convergent, then it's always convergent, right? Right? So when I look at n over n cubed plus 1, I think it's absolute convergent because n over n cubed is it's 1 over n squared. When I'm square, it's convergent by the P series. Okay. So the question is how do you write it? Okay. You should see the convergence before you even write anything. Okay, it's most of the problems are obvious whether it's convergent. The question is how do you argue, right? How do you argue that? Okay. So it's convergent. Right? So when you use a comparison test, the series must contain only positive terms. That's so you are safe if we consider absolute value of this. Okay, this is all the term is a positive. Then you can apply the comparison test. Okay, so how can I use the comparison test? Well, this is the an. Okay, n is going to be n over n cubed plus 1. It's less than or equal to n over n cubed. It's going to be 1 over n squared, which is the bn. Then apply the comparison test. Okay, since bn is convergent, and if we have a minute, you can say by the P series test. Okay, and the P is going to be 2 greater than 1. So then you can conclude that n is convergent. This is convergent because by the comparison test. Okay. Then the series is absolute convergent. Of course, it's convergent by the theorem, right? But I said many times, do not use ratio test. But I find out the students is in favor of ratio tests. For whatever problem, just use a ratio test. It's not working, okay? And if your computation is correct, you will end up with a 1. If the limit of the ratio is going to be 1, it's inconclusive. You cannot use it to jump to the conclusion it's convergent. So this student use a ratio test, okay, fine, and find the limit. Yes, this time no mistakes, 1. Then it's useless. You have to get rid of that. And then because if you remember the ratio test, if the limit is 1, you cannot say anything. Okay? Yeah, you cannot see anything. So I cannot give any credits to the student. First of all, it's the wrong method. You find the limit of the ratio, then stop that. Do not even jump to any conclusion. Oh, yes, it says convergent. Which one is convergent? The ratio is convergent, yes, but I'm asking the series, asking to tell me the convergence of the series. Okay, so this is the only way you can solve this problem is you can solve the problem directly. You view it as like an alternating series. You still can do that. If you view it as alternating series, then this is going to be like that, right? You have to prove, you have to prove this is decreasing to 0. If you can prove this decreasing to 0, that's not my purpose actually. I'll give you 2 options. One is you prove this it's convergent by the alternating series, but then you have to do hard work. to prove it's decreasing to 0. Okay, and this is much harder. Okay, then you can say that alternating series is converged by its alternating series test. So it's not too bad. You can look at the function x over x cubed plus 1, right? And you find the derivative. And nobody used this method, of course, but I think this works, And this is 1 times x cubed plus 1 minus x times 3x squared, and blah, blah, blah. You get the numerator is 1 minus 2x squared. And clearly this is a negative when x greater than or equal to 1. All right, so that's the reason f of x is decreasing, okay? All right, so therefore, Bn is decreasing then. Yeah, Bn is equal to f of n, right? So this series is going to be convergent by the alternating series test. Okay. So when you prove something, you have to quote the text, but you should remember what are the assumptions, what are the conditions in there. You have to verify those conditions in order to apply it. Okay, you want to apply an alternating series test to prove it's convergent, then you have to make sure the series satisfies the condition in the alternating series test. Okay, so this student did not prove that using alternating series. Okay. All right. Again, ratio test. I don't know why it's why using ratio test. I just want to see how many students using ratio test. When I was grading the test, a ratio test. Come on. Why use a ratio test? I said, don't use a ratio test, okay? Only when you see n factorial. That's why you have to put a note when you prepare for the exams, right? You should have your own notebook, key ideas you learned from this course. Okay, one important note is don't use a ratio test if you don't see n factorial or explanation function like 2 to the power n. It's useless. You cannot get any conclusion. If the limit is always equal to 1, of course, by mistake, you will get to 1/2, maybe 3. Then you jump to the wrong conclusion. Okay? But the ratio test is useful for determining the radius of convergence of power series. Because why? Because x to the power n is the one, is the exponent, the power function there. Okay, x to the power n, yeah. So you can use a row test or ratio test, doesn't matter. Okay, and again, this student use a ratio test. Okay, I just want to see how many students use a ratio test. Okay, it's to ratio test. Come on. Okay, so that's why I just give you one. Okay, pay attention. No, don't use a ratio test again for problems like that. Right? Right. All right. So let's continue. So when you really don't have a time before the final exam, you look at my notes. You don't read the solution just to see if you can figure it out. those problems. Okay, and that's the most efficient way to prepare for the final exam. Okay. All right, so the next problem. I just choose any number here, okay? So n plus 1, for example. Yeah, this could be written in another form, okay? But you should combine them. Right? Could be in this form. I put 2 there. 2 is much easier to solve the problem. Let me begin with this 2. Okay. Why? Because this is nth term, right? You immediately you can see that this is going to 2. Okay. The limit is 2. Okay. So this is going to be 0, greater than 0. So the limit of the nth term is going to be natural log 2 is greater than 0, and clearly this is a divergent by nth term test. That's it. Now this student use a comparison test, then jump to the conclusion this is a divergent. So I cannot give it credit too much, you know. Okay, because the argument is not the correct argument for the conclusion. Okay, so then this series is divergent by the nth term test. Okay, but how about the next one? Then this time it's convergent to 0. Yeah, the limit natural log of n plus 1 is going to be natural log of 1, which is 0. Which is 0. So the nth term test cannot be used here to prove it's divergent. Question is it convergent or divergent? Why? Divergent or convergent? Not sure. Well, comparison test does not, it's not to compare, first of all. Okay. And it is divergent. Maybe yes. Let's see. Okay, let's see if we cannot do that. You know, this is a special problem. You can write nth term, right? So that's k, n equals 1, natural log of n plus 1, right? So natural log have a very nice property. It's going to be here's n equals 1 over 2 plus natural log of 2 over 3 plus of natural log of n k of k plus 1, right? This can be become product. Do you agree? This can be become product. It's going to be 1/2, 2 over 3, 3 over 4, and k over k plus 1. So all those terms be cancelled out. You only get 1 over k plus 1. And this clearly approaches negative infinity as k approaches infinity. It's divergent. Right? Okay. It's divergent. Yeah. Another reason I can figure out divergence, suppose you cannot combine, you're lucky in here combine all the terms. Another reason is natural log of n of n plus 1 is going to be negative natural log of n plus 1 of n, right? This is going to be natural log of 1 plus 1 of n. Okay? But remember the Taylor series. The Taylor series, 1 plus x, the first term is going to be what? It's going to be x. Okay? And then the rest of them like that. So this is almost equal to negative 1 of n. Okay? If you have to find the, comparison test that's you compare with 1 of n. Limit comparison test. So this is your n, this is my bn. So all the terms are negative, so you can use a comparison test. You take a negative sign out, right? Yeah. So that's why since this is divergent, so therefore this is divergent. This series is divergent. Okay, by the limit comparison test. Limit. You have to use the limit comparison test. The reason is the limit n approaches infinity me 1. Okay, so there are almost no difference. And when n of n is going to divergent, okay, so that implies natural log of 1 plus 1 of n is divergent. Okay, finally, tell me whether this is a convergent or divergent. Huh?
Divergent.
Why?
Well, because as the inside goes, it approaches 0, and sine continuously goes forever. Right? I know it doesn't prove it, but yeah, like that's what I would start off with. Sine 0 is 0.
Yeah, the nth term approaches 0, but that's not guarantee this is convergent. It's about a similar idea before. Say you have to compare. Oops. Sine x over x as x approaches 0, it's going to be 1. Okay, so that means n approaches infinity, sine 1 over n over 1 n is going to be 1, right? That's it. So this is your n, my bn is 1 over n. Okay, so by the limit comparison test, this is divergent because this series is divergent. So that implies that series is divergent. Okay, by the limit comparison test. Okay. So remember, okay, do not use, if you don't know how to, whether you should use a ratio test, do not use a ratio test twice on the same test. Okay, we're not going to put so many problems, you have to keep using the ratio test, okay? Yeah, the problem is now, yeah. Okay, but not always when you see the exponential function, you should use a ratio test. Sometimes it's harder to use a ratio test. Okay, okay, let's look at this problem. Now this can be 3 to the n, okay, and 2 to the n, okay? And clearly this is going to be convergent, okay? And you can use a ratio test, you can use a root test. This is a place you have to use, okay? So you can use a root test, okay? It's going to be nth root here and 2 over 3, okay? Then the limit is going to be 2 over 3 as n approaches infinity, and that's it. So the L is going to be, the limit is going to be less than 1. So that implies the series, not this, it's the nth term. So that implies the series is convergent. Okay? By the load test. Okay. But not always you can use that. Okay? For example, 3 to the n, 4 to the n minus 2 to the n. Okay? Or plus 2 to the n, or minus the minus is a little bit more difficult. Okay? Now, whether this series is convergent or divergent. I think it is going to be convergent. But you cannot use a ratio test, cannot use a load test directly. Right? The denominator is almost equal 4 to the n. Because 2 to the n is compared to 4 to the n is much smaller. Right? So the question is, you want to prove that it's convergent, you have to use a limit, right? So you can ignore the same. Right? So you can ignore, right, 2 to the n. So that's my bn. That's my n. So you're surprised you're going to use comparison test instead of a ratio test. Okay? So an over bn is going to be 3 to the n, 4 to the n minus 2 to the n divided by bn, so you turn upside down. So this canceled out. And then you will divide by numerator number 4 to the n. Okay? This approaches 1 as n approaches infinity. Okay. Okay. Yeah, I'm like next semester I'm not going to use this class. So I'll go back to LD building. This is yeah, equipment's over there. It's much better than here. This is information school of informatics. All right, so the limit is going to be 1. Therefore, those two convergence, those two series have the same equivalent convergence. Okay, but I know this is a convergent, right? And the 3/4. This is a geometric series, right? That implies the power series. Yeah. So you should see the result before even trying to prove it. Right? And so you have to, here we use a limit comparison test. Okay, sometimes you can directly use a ratio test, the comparison test. If it's not minus, here is +2 to it. Then you use a comparison test. That's much quicker to solve the problem. And finally, go back to power series representation. Okay, find a power series for power series representation for the following function. Oops. I don't know what's going on here. All right. If I ask you to find the Taylor series, you're unable to find the partial. You cannot find the derivatives. So complicated. It's a fraction. You can only get a few couple terms. That's not enough. right, let me work out this problem. So step one, yeah, you let u to be x minus 2, right? So you're going to expand that. Good. So the function is going to be, here's just u. X is going to be u plus 2, then plus 1, right? It's going to be 3. Okay? So it's going to be u, 3 plus u. But since the numerator is u, so you can keep it aside. So you get u times, take 3 out. Right? Then you expand it. I think it's negative. Okay? That's a negative sign. Okay, why it's negative? Because you have to express it like a 1 minus negative u over 3. Okay? Then you apply the formula. So now you get negative 1 to the power n, 3 to the n, and the u to the n. Okay? You multiply this out. No, that's just u to the n. And here's u to the n plus 1. Okay? You can label them. You can n plus 1 can be k starts from 1. Right? K starts from 1. You can say that. It's 3 to the power k, negative 1 to the k minus 1. And u is going to be x minus 3. No, minus 3 minus 2. I forgot. Yeah, minus 2. That's it. So this is a power series. So first term is 0. Okay? I said that you must learn how to use this idea to find the power series representation at any given point. Okay? If you want, if you don't want to lose that 10 points on the test.